In this problem, we're going to find the empirical formula and then the molecular formula of an unknown compound. The problem says, a compound is analyzed and is found to have the following composition by mass: 69.9% carbon, 7.83% hydrogen, 22.21% oxygen. The molecular weight of this compound is 360 grams per mole. What is the molar formula of the compound? The first thing we're going to do is assume that we have a sample that is 100 grams, because this is a very convenient number. If we have 100 grams of sample total, that means 69.96 grams of it will be carbon, 7.83 grams of it will be hydrogen, and 22.21 grams of it will be oxygen. We're merely using 100 because it's a very convenient number, and we don't have to do any math to find out grams. Now, in order to figure out the ratio that you have in the coefficients in the equation, we're going to have to convert the grams to moles for each of these compounds. So for carbon, we could take 69.96 grams of carbon and there are 12 grams of carbon in 1 mole of carbon. So that gives us 5.83 moles of carbon. We do the same thing with hydrogen. 7.83 grams of hydrogen. And there's 1 gram of hydrogen and 1 mole of hydrogen. Gives us 7.83 moles of hydrogen. Then 22.21 grams of oxygen. And there's 16 grams of oxygen and 1 mole of oxygen. And that gives us 1.39 moles of oxygen. So we have 3 quantities here in terms of moles, and we're going to look at the 3 numbers. The lowest number among these is 1.39 moles of oxygen. So we're going to use that to find the mole ratio for each of them. So for carbon, we have 5.83 divided by 1.39, which gives us 4.2. For hydrogen, we have 7.83 divided by 1.39, which gives us 5.6. And then for oxygen, of course, this is all based on oxygen. So 1.39 divided by 1.39 is 1. The reason we're using the lowest number is because if we assume there's 1 of the lowest number, we'll see how many of the higher numbers there will be. You'll notice that these 2 numbers are not whole numbers, so we need to find the lowest number that we can multiply these by to get whole numbers for each of them. And in this case, let's try 5. 4.2 times 5 is 21. 5.6 times 5 is 28. And 1 times 5 is 5. This would suggest that the formula is C21 H28O5. We were given the molecular formula back in the problem. It says the molecular weight of the compound is, we're given the molecular weight. The molecular weight of the compound is 360 grams per mole. So let's go back to our formula and check. So 360 grams per mole was what was given in the problem. And let's see what we get. There are 21 carbons times 12 for the molar mass of carbon, 28 hydrogens times 1, and 5 oxygens times 16. And that gives us 360. So this ends up being the correct molecular formula and empirical formula, because 21 is a prime number, as is 5. So there is no reduction of this formula. If we'd gotten a small multiple of 360, then we would know we had to multiply all of the subscripts by whatever factor of 360 this was. So if we got 180, we would multiply all these by 2 to get the molecular formula from the empirical formula. And that is how you find the molecular formula. Just to recap, we took the percentages. We said we had a 100-gram sample. So then the percentages were the same as the grams. We took each of the grams, changed it to moles. We identified the smallest number of moles. We divided each of these by the smallest number of moles, and we got values here. 2 of these were far off from whole numbers, so we found the smallest factor that would give us whole numbers for each of these values. We put them as subscripts. We calculated the molar mass, and we compared it to the molar mass that was given in the problem. And that was the empirical and molecular formula in this case.